Okay, now this next question, question 7, is really going to derive an important formula for the, or an important equation that describes a trajectory, a general equation which describes a general trajectory of a particle. So when it's projected in the usual sort of way. So it'll be useful. It's a useful little exercise. So it says the flight of a particle projected with an initial velocity of u at an angle alpha above the horizontal is modelled as a projectile moving under the influence of gravity only. Okay, and the origin is defined to be the point from which the particle is projected, with upward direction taken as positive in the vertical direction, as the positive vertical direction. Show that the x coordinate of the particle at time t seconds is given by x equals u cos alpha t. So this is sort of what you do every time you deal with one of these projectile problems. So we can almost, this is trivial, part A. So this is 7A. So let me just move the paper up so that we can make sure that we've got everything on the screen. So what have we got? We've got a projectile. Okay, there's a horizontal. It's got an initial velocity u. It's at u. It's makes an angle of alpha with the horizontal, and we're interested in showing that the x coordinate of the particle at time t is going to be given by x equals u cos alpha t. Right, so these are we're going to, so this is going to be treated as the origin of our axes, and these are going to be treated as x, y. The vertical is going to be the y direction, and the horizontal is going to be the x direction. Okay, so these are our usual x, y coordinates. So these are Cartesian coordinates, and this is going to be our projectile. So the particle at some time, so if this is a general point on the path of this trajectory, it's going to have, after a certain time t, it's going to have an x coordinate of x, and it's going to have a y coordinate of y. Okay. Now we're not interested in y at the moment. We're only interested in x for part 1, but I'm going to draw the y on there. So that's going to be y, and this is the particle. This is the projectile, or the particle at time t. Okay, so what do we do with it? Well, what have we been doing with all of these projectile type questions? And if I can get my, I don't know how well colour looks on these videos, but anyway, I'm going to resolve this. Here's our velocity u, initial velocity. So I'm going to resolve that into its horizontal component, u cos alpha, and its vertical component, which is going to be u sine alpha. Okay, and I'll draw that over there. So we've got its two components, u cos and u sine alpha. Right, now we're only going to look at the horizontal motion for part 1. So, and we've been told, by the way, that when we come to our vertical considerations, that we're going to take upwards as positive. But that doesn't matter at the moment, because acceleration is, I'll put acceleration on this diagram because I'm going to need that. So A is going to be acting downwards, and that's going to be equal to, well, we don't know what A is, but so A is going to be G. Usually we use the symbol G for the gravitational acceleration, so I'll just call it G. Okay, so part one is, so where is it after a time t, if it in this diagram? So consider horizontal motion, and we're going to take the direction to the right as positive. Okay, so what do we know? Well, there's no acceleration horizontally, no acceleration at all. Our initial velocity is u cos. Our initial velocity is going to be u cos theta, and therefore, just like we did in the last question, and this is part one, by the way. What we're going to do is we're going to say S equals ut plus a half at squared. That's our Suvat equation. A equals naught. U is going to be equal to u, in this case, u cos alpha. I know this looks a bit strange when you say u equals u cos alpha. What we're actually saying is that we're going to, the u that we use in this general Suvat equation is actually this big, actually think of this as a big U, capital U. U equals capital U. So these are actually capital U cos alpha and capital U sine alpha. So we're going to treat those as capitals. So initial velocity is u cos alpha, and our acceleration is 0. So we know that therefore the and s is going to be the value of our x. What we call x on this diagram is going to be the distance that we've displaced from x. So therefore, when we substitute these into this equation, we get that therefore x is going to be u cos alpha times t. And that's what we were asked to show, u cos alpha t. And that's what we were asked to show in the question. X equals u cos alpha t. So it's all follows on from there. Okay. Now let's look at 7b. Move on to 7b. It says show that the y coordinate of the particle at time t seconds, the y coordinate, is given by y equals u sine alpha t minus a half gt squared. And we've been told to take the upward direction as positive, so dead easy. Exactly what we've been doing in all of the other previous questions. So part 2 is to consider the vertical motion. With the upward direction as positive. Now this time we've got A, the acceleration is negative because G acts downwards. So A is minus G. U, the initial velocity, so we're still going to use this Suvat equation, S equals ut plus a half at squared. Okay, but this time we're considering the vertical motion. So u is the initial velocity in the vertical direction, which we said was u, which is going to be big capital U sine alpha. T is going to be just t. A is going to be minus g. and S, the displacement, is going to be the value of y. Okay, because the displacement is going to be the y value of the particle at that time. Okay, so we end up with S equals y. So substitute into this equation, we get therefore y equals u, big U, sine alpha t. Because A is minus g, it's going to become minus a half gt squared. Okay, and that's what we've been asked to show in the question. Y equals u sine alpha t minus a half gt squared. Okay, so that's pretty straightforward. Now, I'm just going to fold this over because it's so we now want to look at part C, and part C is to hence show that the trajectory of a projectile is given by this equation. Okay, and at first you think that's quite a horrendous looking equation, but don't worry about it, it's dead easy, because now that we've got our two equations, don't forget, from part 1 we know that x equals u cos alpha t, and from part 2 we know that y equals u sine alpha t minus a half g squared. So what we're going to do with part 3 is I'm going to go back to equation, if I call this equation 1 and call this equation 2, I'm going to go back to equation 1 and get an expression for the time t in terms of x and u and cos alpha, and then I'm going to substitute for t in the equation 2, get rid of these t's, and then I'm going to do a little bit of trigonometry, and then hopefully we'll pop this equation, because you'll notice that this equation that we've got here doesn't have any t's in it. It's only got x's and y's and alphas and u's and g. Okay, it's got no times in it. Okay, so let's do that. So from equation 1, if you rearrange this, we get t equals x divided by big U cos alpha. Okay, t. So all I've done is rearrange this to get t on its own. So you get x divided by u cos alpha. Now, next thing is I'm going to say sub t into equation 2. Okay, I'm going to substitute for t in this equation. So what do I get? Well, I'm going to get y equals big U sine alpha times t. Well, t is x over big U cos alpha. Okay, that's that t. Then we've got minus a half times g times t squared. So it's going to be, I might just do this, I'll write this as x over u cos alpha all squared. Right. Now, this is where the trigonometry comes in, because the u's cancel out, and we've got sine alpha divided by cos alpha, which you remember is tan alpha. Okay, sine alpha divided by cos alpha is going to be tan alpha. Now we've got an x on the top line, so this is going to become x tan alpha. And this thing, well, we're going to have a minus g x squared, because that x, this squared is going to become an x squared on the top line, so there's going to be a g and an x squared, gx squared, and on the bottom we've got this 2, and we're going to have u cos alpha, but u cos alpha squared, so the u times u is going to be u squared, and the cos alpha times cos alpha is going to be cos squared alpha. Okay, now let's quickly go back and see what we've got, and there we go. Y equals x, or tan alpha times x. I've got almost the same thing. Minus g x squared over 2u squared cos alpha. Now this formula is going to be so that's the end of that part, but it's just worth noting that this formula is going to be very useful because you can solve this, you can find all sorts of information by just plugging in the initial velocity and the value of acceleration due to gravity and alpha into this equation, and it predicts where the y values for the various situations. So it's quite a useful formula. Okay, leave it at that.